This video is going to be a short one with some use of examples involving natural log. So let's go ahead and just get started. The first one we're going to do has some trig in it, which is not something we may have seen yet. So let's say we have secant squared x in the numerator, and then in the denominator 1 plus tangent x dx. So a good candidate for the u in this case might be either secant x, and if u is secant x, then du would be the derivative of secant x, which is secant x tangent x dx. But if you notice, this is not present in the numerator of our expression, so this makes this a bad candidate for u sub because we cannot find the variable part of the du. Instead, let's try the denominator of this, 1 plus tangent x. So if I say u equals 1 plus tangent x, then du would be 0 plus, the derivative of tangent is secant squared x dx. And then we can notice that we have secant squared x dx as the numerator of our problem. So this is good, because now we can rewrite this. This becomes integral. The du is the numerator, it's secant squared x dx. And then the original integral just gets rewritten as 1 over u du. Now we can use the natural log rule. So this is natural log absolute value of u plus c. And again, we add the absolute value because this could be positive or negative, but the domain of natural log is restricted to only positive values, so we have to take the absolute value of the inside to make it positive. And then finally, we substitute the u back inside, so we get natural log of 1 plus tangent x plus c, and that would be our final answer. Notice that this is the integration step where we take the integral of 1 over u du and make it natural log of u plus c. Let's do another one. Let's say we have the integral of dx over the square root of x times square root of x plus 1. Okay? If the dx over the fraction makes you a little bit uncomfortable, that's okay. If you want, you can rewrite it as 1 over square root of x, and then parentheses square root of x plus 1 dx just on the side. That's totally okay, as long as you leave the 1 at the top. So let's go ahead and identify the u, and a good candidate here is going to be the inside of these parentheses. So we're going to say u equals the square root of x plus 1. You can rewrite this as x to the 1 half plus 1, and that's going to be easier for taking our derivative. So the derivative here is going to be 1 half x to the negative 1 half dx. And so now you have to ask yourself, okay, do I have dx? Yes, I do. Do I have x to the negative 1 half? And you're like, well, I don't have anything up here, but wait, x to the negative 1 half is the same as 1 over the square root of x. So this square root of x, which is just sort of chilling here out front, really, that 1 over square root of x is part of the du. And then we have this 1 half. I don't have the 1 half in the original equation, so I have to doctor with a 1 half, having that 2 in the denominator, and then counterbalance with a 2 on the outside. So there's a couple more things here with this. So when we do this, the counterbalance of the 2 will be there. We will have our integral, and then all of this 1 half, all of that 1 half, 1 over root x, and the dx, all of that is du. So that all goes into the du. And then what we're left with is 1 over u. Because the leftover stuff was just this root x plus 1. That's the u, so that goes in the denominator of our thing, of our integral. And then we have 2 integral. Oh, no, we're going to do the integral. That's natural log of absolute value of u, because we're doing the 1 over u rule, plus c. And then that becomes 2 natural log absolute value. And then we have the square root of x plus 1 plus c. And again, here's the type of problem where you can drop the absolute value because the square root of x always gives you a positive number or 0, but because we're adding 1 to it, that means that this expression, this square root of x plus 1, will always be positive. Therefore, we can drop the absolute value to get the square root of x plus 1, like that, and then plus c, that will be your answer. One more example. Let's say we have the integral of x cubed plus 7 over x. And you're like, what? This is kind of weird, right? Because I'm looking at these exponents, and this is not a difference in exponents of 1, for sure. And instead, what you want to do here is use algebra to rewrite this first. So we can just bring the x up to the top, so you x cubed plus 7, Bringing this x up makes it x to the negative 1 dx. And now you have a product, but you can't integrate a product, so we're going to distribute the x to the negative 1 inside, giving us x squared plus 7x to the negative 1 dx. When we integrate this, well, the x squared, that's just a power rule. So that's just going to be 1/3 x cubed. This, however, that's like kind of weird, right? So we can rewrite this, or it might be more convenient to rewrite it as 7 over x dx. And then if you notice, that's really, if we move the 7, it's really 7 times 1 over x. So when we integrate this 1 over x, that's where we're going to get natural log. So the integral of this x squared is the 1/3 x cubed, plus 7 is a constant multiplier, so it's going to stay there, and then this integral of 1 over x is where the natural log of absolute value of x would be, and then plus c. So that would be your final answer for this problem.